Hi Patrick, why those fancy clothing today? Anything fun?
Hi, Sunny. My stylist is always the best.
Yeah, those clothing definitely looks great on you.
Thank you.
Where are you going?
I'm going to Bora Bora. I love to see my private islands. Yeah.
Wow, nice choice. Must be a long flight from here.
Yes, it is. My driver is waiting outside. I have to go.
Oh, okay.
See you later.
See ya.
Hey, what's up, guys? I'm a boarder here. So, almost I would like to fly back to China every break. It takes me like more than 13 hours on the flight, and I also need to suffer on the car. So, I would like to someone help me to figure out which is the best time for me to go to the JFK so I can save some time on the car. Thank you.
Oh, good day, comrade. Good day, comrade. What are you going to do?
I'm going to watch a basketball game in Los Angeles.
Very good, very good, very good.
Yes. Zachary Fazino.
Go.
Are you Team Zach or Team Whoa? Team Zach.
Team Zach.
How
Okay,
are you
wonderful.
going to get to the game?
On Friday, I am going. On Friday, I am going to the JFK, which is better than LaGuardia,
Oh,
and,
yes.
and I will be leaving at 8 p.m. on Friday.
Hi, Mr. Drooping.
I'm out actually. I gotta go see Mr. Schnurr about going to Florida. We're out.
What's the
Yeah, I mean, like, we really gotta get going now. Like, I'm out. So just shoot me an email. Like, I'll catch you, but.
Hola, pues yo soy residente en Estados Unidos y viajo mucho en avión. Viajo mucho desde el aeropuerto de JFK, pero es un asco, porque está muy bien que los aviones van rápido, los viajes de una parte del mundo a la otra parte del mundo son muy cortos, pero el día que tienes que coger el vuelo, el proceso que hay en el aeropuerto es horrible, porque primero que tienes que viajar en un coche o en autobús o en tren hasta el aeropuerto, porque para llegar a JFK, nosotros desde Connecticut tenemos que utilizar ese transporte.
Okay, so our group is having a project analyzing the minimum amount of time used on traffic. Specifically, it's based on from your house or the campus to the airport. From the previous examples, we can see many people have the needs of going to the airport, whether from campus or their home. So we are having an analysis based on how to get how much time are we using to get to the airport from our campus by using calculus. First, we gather the data on December the 6th, Friday, which is a Friday, and we gather the data in which the time consumed from our campus to JFK Airport from 12 o'clock p.m. until 12 o'clock a.m. the next day. And these are the data we gathered, and together we can have a huge graph of showing the different time used to go into the airport. And we are using the calculus, including the first derivative test, second derivative test, and extreme value theorem to get the minimum time used in each time interval of an hour from 1 o'clock to 11 o'clock p.m. Like when we are using Excel to gather the data, so there are some differences between the actual time and the actual number which is used on Excel. So this is the conversion between the two numbers of time and the number of Excel that it used.
So as you can see, these are the data we collected for the time period of 12 p.m. to 3 p.m. And then through these data collected, we can get one best fit line. So this best fit line can be the best representation of the data we collected from the time period of 1 p.m. to 2 p.m. Through this, we can get one first derivative, which is, as I will write it down here. So now we get this first derivative function. We can find its zeros, which are 0.51 and 0.61. So, as we can see, the boundary, the range of 1 p.m. to 2 p.m. is 0.54 and 0.58. Those two zeros are not within this range. So therefore, we can say there is no smallest number in this range. These are not the smallest ones, and therefore we do not need to use the second derivatives test. Therefore, we can continue to do the test intervals, which will find that $121.58 is for the 1 p.m. and 146.72 is for 2 p.m. Through this, we can find the digit of 1 p.m. is smaller than the 2 p.m. Therefore, the times taken from Treasure Academy to the JFK airport is significantly smaller in 1 p.m.
Okay guys, so here's the curve. It's from 6 p.m. to 9 p.m. and this is the best fit line and it represents the trend. Then we can find the first derivative. The first derivative of this best fit line is Then, in order to find the critical point, we need to find the zeros. So here are two zeros. The first one is 0.71 and the second one is 1.08. And neither of them are in the interval, so we don't need the second derivative. And then we need to test the intervals. So we plug in the 0.79 and 0.83 into the best fit line, and we got two results. The first one is 117.105, and the second one is 110.524. So compare these two, the second one is smaller, and then so we can get a solution is that we recommend you to go like JFK later, maybe at 8 p.m.
Okay, this is the best fit line from 8 p.m. to 11 p.m. So this can be a great representation of the time trend from 9 p.m. to 10 p.m. And as we can say, the formula is written here. So we can have the best fit line. In order to find the trend of the best fit line, we need to do the first derivative test. So we need to get the derivative, like the first derivative, which is this. In order to find the critical point, we need to find the zeros of the first derivative. And the zeros for the first derivative of this function is 0.89 and 0.95. Since this interval is from 0.87 to 0.92, so 0.89 is in the interval, so it could be a local extrema. So we need to find the second derivative and do the second derivative test to see if 0.89 is the local extrema, like the local maximum or the local minimum. So the second derivative is this. Okay, when we get the second derivative and we want to plug in x equals to 0.89, and in this situation we got the value of 3,382.54, which is positive. Since this is a positive number, we can tell that this function, like for this part, is concave up. So for concave up, it have the local minimum. So we are going to plug in the value for 0.87, 0.89, and 0.92. So for 0.87, we have approximately 102 minutes, and for 0.89, we have approximately 101. No, 101.5, 0.6 minutes, and for 0.92, we have 102.594. So for 0.89, since this is the value for the Excel in Microsoft, so we are converting this 0.89 into the actual time, which is 9:21. So if you are traveling between 9 o'clock to 10 o'clock, we would recommend you to go at near the time of 9:21.